Hi, I'm Dr. M. Uma, Associate Professor. I'm going to discuss about the regression analysis in machine learning. So first we should know what is the machine learning, the definition of machine learning. Machine learning is the application of artificial intelligence that enables a system to learn and improve from the experience without being explicitly programmed. This is the difference between normal program and machine learning. It is automated. Then there are different types of machine learning. One is supervised machine learning and unsupervised machine learning. Supervised machine learning algorithms are trained using the labeled data, and unsupervised machine learnings are trained using unlabeled data. That means we should and the input, we know the input variable, but we don't know the labeled variable. That is unsupervised. But in supervised algorithm, the input and output is a known. That is supervised machine learning. Then normally in supervised means in the regression and the classification problems are the part of the supervised learning and the supervised machine learning, and unsupervised normally we are referring as a clustering and association algorithm are part of the unsupervised machine learning. Regression analysis. A regression analysis is a statistical method to model the relationship between the dependent and independent variable with one or more independent variable. That means here the dependent variable is output variable and independent variables are input variable or feature variables. And using regression analysis, it helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are fixed. Then normally using the regression analysis, we can predict the continuous and real value, such as temperature, age, salary, and price, etc. Suppose in the given example, suppose there is a marketing company A who does various advertisement every year and get a sales on that. So the 5 years of details they given, that is advertisement cost, they spend the cost they spend the amount for the advertisement every year, and it's a sales, corresponding sales. So we should predict when they spend $200, then what would be the sales. So for finding the this kind of the prediction, we can use a regression analysis. So normally regression is the supervised learning and which helps in finding the correlation between the variable and enable us to predict the continuous output variable based on one or more predictor variable. Mainly used for forecasting time series modeling, we can use this regression analysis. Then real-time example, we can prediction of a rain using temperature or some other factors, and determining the marketing trends or prediction of road accident due to the rash driving. These are the use cases we can use regression analysis. So then some of the terminology we should know in the machine learning course. First of all, we should know what is a dependent variable. Dependent variable is nothing but is output variable or labeled variable also we can say. Independent variables are feature variables or input variables and also called as a predictor. Then outlier. Outlier is nothing but it is observation which contain either low value or high value in comparing to other observed values. An outlier may hamper the result. It should be avoided. Then multi-collinearity. If the independent variable highly correlated, suppose in your data set, you have highly correlated values, more than one features, then definitely you should remove one features. Okay, when you are using more than one highly correlated value, it will affect the result. So because it creates a problem while ranking the most affecting variables. And we should know what is underfitting and overfitting. If our algorithm work well with the training data set, but not well with the testing data set, then this is called as a overfitting. And if our algorithm does not perform well, even the training data set, then this is called as a underfitting. There are different types of regressions: linear regression, logistic regression, polynomial regression, support vector, decision tree, random forest, ridge regression, lasso regression. So there are many different regression algorithms are available. So based on our use case, we can use any one of the regressions. The linear regression. So I'm going to focus on linear regression. It is simple. It is also called as a simple linear regression because we are going to find the relationship between the dependent variable and independent variable. Okay, that is x variable and y variable. So it is called as a linear regression. If there is only one input variable we are using for comparison, means x and y, then it is called as a simple linear regression. That is only one input variable, then one dependent variable. If it is more than one variable, then it is called as a multiple linear regression. Then in this example, see here in x-axis they used experience, the year of experience. Then in the y-axis they use as salary. So if it is 2 years of experience, what is their salary? Then if it is 4 years, 6 years. So when the experience come as a new data, then you have to predict the salary. So using the simple linear regression. So you can use in the mathematical equation y equal to ax plus b. Using this, you can find the you can find the prediction. So here y equal to y is the output variable. Then you have to find out the a of ax plus b. Here x is the independent variables. Then b is a and b is the linear coefficient. See here in this example, all the green color dots means small circle are actually the data sample points given. Then the line, the black line is a predicted values. So we have to find out whether the line is giving the best fit or not. So based on the differences between the actual value and predicted value. So the actual value and predicted value difference is minimum, then it is a good fit. See here in this example, the independent variable is always in the x-axis and the dependent variable should be in the y-axis. All the data points and the lines are called as a line of regression. Then if the relationship between the x and y is positive, means is positively correlated, that is positive linear relation, and the difference means the relationship between the x and y is the negatively correlated, means it is called as a negative linear relation. Then you can implement the linear regression model, you can the prediction model using Python. Okay, so before implementation, you should use all the necessary importing the libraries you should import. Then you can use pandas, numpy, and matplot library, etc. So all the required libraries here I use. Import pandas pd for creating the data frame, and numpy as an np, that is it support for numeric variable and arrays, and matplot for plotting purpose, and cborn for loading the data set. And you can create a data frame for loading calling the CSV file. So here then house prediction data set consider for the prediction model. Then so you can use the read CSV for reading the CSV file. Suppose if the data set is in Excel, then you can use the read underscore Excel. Then once the after loading the data, then our next step is visualizing the data. So data visualization is very important part in the role of a data scientist. It is recommended to visualize the data. Visualize the data, so you can find any correlation between the different parameter. So here you can figure out using the plot, and you can use the heat map for showing the matrix format, all the data sets with the different color. And you can using the show function, you can display the heat map. Then feature engineering process. So third step is after while you're visualizing our data, we have to find out the strong correlation between the two parameters. So you can choose the parameter. Suppose if it is one input variables, and one output means it is a simple linear regression. So we are using square feet, living, and price. For selecting the required parameter, you can use the data frame, then give the input variable, and the same using data frame, you can give the output variable. So all the array will be stored in the X and Y axis, then means input independent variable should be in the X variable, and output variable should be in the Y variable. Then you should call for the fitting the linear regression model using train test splitter. So normally the standard training and testing the data, we can use the ratio 70-30%. It means the whatever the data set we are having in the sample, 70% will be considered for training the data, and remaining 30% for the testing the data. Then so import all the necessary packages. Some of the packages, the library is already given, so you can use the built-in libraries. Then you can use the variable for X train, X test, and Y train, Y test variables for specifying the X input variable, Y variable. And here the test size specified 0.2 means 20% we consider as for test variable, remaining 80% for training, and random state you can specify 0. You can change it and you can observe the output. Then here then Y train, that is once you train the model, then you have to give the sample test value, and then it will predict the Y. So based on the prediction, you can find out whether it is a good model or not. So for that, you can find out the difference. Means you have to find out the difference, that errors is minimal, then it is a good model. Then here the Y test dot reshape for changing a single feature, and call the linear regression model, then fit the X train with the Y train. Then you should calculate the after linear regression is important. Then you can fit over the training data set. Then intercept and coefficient of our model can be calculated using the model dot intercept and model dot coefficient variable. Then predict the X test. Then pass the X value, means X test value. Then predict the output. So you can, here we are using the reshape for changing to the single feature dimension. And necessary, that is, you should find out the mean squared error. When you are finding the mean squared error, then only you can find the model, whether it is the model is fit or not. So find out the mean squared error. Based on the mean squared error value, you can conclude that this model is better model. So the performance of the model can be evaluated by finding the root mean squared error of the model. So lesser the RMSE, better the model. So these are the resources I refer. It would be very useful. Thank you for the listening.